Hello. Thank you all for joining. This is my first time. I've been to this meeting lots of times. This is the first time I speak. I always enjoyed in this meeting the knowledge sharing, the community sharing. I think it makes this place unique. But I always find there is something missing. One thing that I think is missing is the customer input, the customer voice, the stakeholder voice, and I think that's what we're here to cover a bit. Maybe another thing missing is more fruit, but maybe that's a distant second, right? So so we're going to talk about when our business, Booking.com, came to us with something that you would think is a very simple request, a very simple answer, a very simple question to answer, but it proved to not be that simple, and we went through multiple years, I would say, trying to answer this question as best as we can. We now think we are in that place, and that's what we came here to talk to you about. Now, the question was, how do you know that your database, for how long is it up, and how do you know? Now, some of you may think that's an easy question. I just go into I SSH to the MySQL, I press, what's the command, I forget?
Systemctl.
Systemctl, status, MySQL dig, and then there it is, it's there, right? But if you answer that, you kind of prove my point for me, right? That is not something that an executive will be interested in. So, let's go over a bit of the agenda. We're going to talk who we are, basic facts about Booking and how we run infrastructure. We're going to define a few terms so we are sure that we're talking about the same thing. We're going to go over the steps that we took, control, approximation, adaptation, and truth. We'll look at a little bit of the market. What does the cloud community have to say, and how do they solve these problems? And we're going to finish with Q&A. So, who we are. My name is Spiros. I'm a group product manager for database and cloud at Booking. Initially in engineering before moving to product management, and being at Booking in what we call application data services since 2019. Now, I know that the reverence and respect product managers get in this area. Yeah. I've seen all the blogs, I know what you stand for. That's why I brought the engineering muscle with me, and my colleague Mohammed will take it over.
I don't know about the muscle part, but yeah, I'm an engineer indeed. So, hello, my name is Mohammed. I am a senior site reliability engineer at Booking. I have 16 years of experience in system administration, MySQL administration, and site reliability engineering. I come from a computer science and bioinformatics background, and I have been working at Booking since 2018, so almost 8 years, and always have been in the application data services department, managing databases, including MySQL. So, some numbers just to impress you. So we have about 100 million active users every month. Those are the logged in users to our application, in addition to users that we don't track as well, who are not logged into the application. Since 2010, 4.5 billion reservations happened. Guests arrived at accommodations. By the way, I'm sure everybody here knows what is Booking.com. Probably used it to book your accommodation here. But it's not only accommodations, we have taxis and car rentals in 120 plus countries around the world. We host over 200 million reviews for the accommodations that we have. We have different types of, what is the number? I think it's 30 different types of accommodations: home, apartments, villas, bed and breakfast, hostels, everything that you can think about. And we do all of that from 70 different countries with 140 offices, and with the headquarters in Amsterdam with over 5,000 employees. And all of that is backed up by one of the largest MySQL fleets in the world in terms of data size and in terms of number of servers as well. So MySQL is the main and relational is between quotes here, because MySQL is the main data store at Booking, or was the main data store at Booking for a long time before we introduced other databases like NoSQL databases, document stores, etc. So up until that time, and probably until now, We still have document stores in MySQL. We still have queues running on top of MySQL, logging, etc. So all usages of data stores were covered by MySQL, and gradually we are introducing the right database management systems for these use cases. We have thousands of MySQL servers organized in 350 clusters. We do functional sharding, so each of these clusters is holding different data, different tables, serving specific business purpose. And each, we call them clusters or replication chains. We prefer replication chains, and each replication chain, based on the load it gets, it can be in the order of tens or hundreds of servers. We use a single primary for read-write, either with group replication or with traditional semi-sync replication. And we scale out reads through the replicas based on the load. We use multi-tier replication so that the primary isn't overloaded with connection with the replication client. So we run in a 3-tier setup. MySQL runs also on 4 different platforms. So we run some servers on bare metal, on OpenStack as private cloud. We are replacing OpenStack now with our own private cloud that was developed in-house. And of course also EC2 for cloud workloads. In addition to that, we also have some RDS and Aurora clusters used for production workloads. The footprint isn't as big, but it is starting to gain traction. And we also have a completely isolated network environment for testing and QA, and we do periodic copies of data or schemas based on developer needs from production to that environment, daily or weekly, based on the needs. So this is how a typical replication chain would look like. We have here applications, read-write traffic goes to the primary, and then we have 3 regions. We have intermediate primaries in each region. Those act as sources for the read-only replicas and also stand by for the primary. They could be group members in a group replication setup or just semi-sync replicas for the primary. And then we have here the read-only replicas. We can scale that as much as we want based on the load. These read-only replicas are organized in what we call pools. Those pools are basically groups of servers that are serving more or less the same type of workload. This helps in a few aspects. First, isolation of batch processing from real-time processing, so that batch processing doesn't impact front-end traffic. And at the same time, it helps with minimizing the active data set so that it fits in the buffer pool and everything is served from memory. Those pools are, the whole service discovery stack is based on Zookeeper. We use a daemon called ZooAnimal to announce servers based on a health check, and another service called ZooRoster, which subscribes to parties in Zookeeper to get the pool membership, and based on that, it decides which server it connects to for reads. Now, this is the search results page, one of the most famous pages that we have, and one of the most heavy pages that we have. There is a lot of information here. This information is mostly coming from MySQL. You see the user data and the Genius levels, etc., from a non-replication chain called GeniusDB. We have information about currencies and locality, and all of those also come from MySQL. Properties, property search is based on property details stored in MySQL. Reviews are stored in MySQL. Photos are not stored in MySQL, luckily, but all their metadata are stored in MySQL. And property details, including geolocations, and we use the geo data types in the special data types in MySQL. Promotions and marketing campaigns, all of that go through MySQL. Filters, AI is based on our machine learning platform, and our machine learning platform is doing data imports or data exports out of MySQL. And in order to render this page once, we do up to 200 queries to different replication chains in MySQL. This page is shown at least 10 million times every day. So you can imagine the scale now based on these numbers. Now, yeah, thank you. The boring part, I guess?
Yes. So let's talk definition, because for some of the things we're going to talk about, people use these terms interchangeably, and that's not very correct. So SLIs, service level indicators, that's a measurement. We're just measuring something provided by a service provider or a customer. SLOs, this is an agreed upon performance target. So we're measuring something, and we say we have a target for a specific measurement, that becomes the SLO. And for some cases, there is an SLA, which is a legal thing. At this point, lawyers have to be involved, and then this is protected, and this is, let's say, guaranteed by the service provider. Now, the relation between all of them is the SLI is the more broader thing. They are the basis of everything. So let's say, for example, let's move away from databases. Let's say we are making a car, right? We might say we are interested in, I don't know, top speed, 0 to 100, and consumption. All of these things can be our SLIs. We are measuring these things we are interested in. The next level is, okay, how many of those we will have a goal for? For example, we might say, you know what, let's worry, not worry about top speed, we'll leave the Lamborghinis worry about that. We will focus on 0 to 100 and consumption. So we'll have two goals. One will be 0 to 100 in 5 seconds, and less than 5 liters consumption per 100 kilometers. That will be our goals. We will work towards those goals, and we will make sure we are measuring and monitoring them closely. And then there are the SLAs. Okay, we say, okay, maybe we cannot achieve the consumption part. How about the 0 to 100? Right? That will be on a, we will have actually a target, an SLA, and we'll say, we will give you 1 million euros if we cannot get to the car to get from 0 to 100 in 5 seconds. Of course, there will be the specific lines of demarcation. This is important. When we say this, we will also say if there is no headwind, if you're not drunk, if your tires are okay, if there is no ice. We will say all these things to make sure that we don't pay this 1 million euros, almost never on very extreme cases. So we try to create a story and correlate something different to SLIs, but they are similar in a sense. I don't know how many of you know the Maslow hierarchy of needs. This is an American psychologist that said that the needs of humans go in a ladder. You start with the more important things, and once you complete that, you go to the next level and then to the next level. The basic level is physiological, is food, water, heat, shelter. These are the basic stuff. And once you get that, you can go to the next one, which is safety. Am I safe financially? Am I safe psychologically, physically? Once you get that, you get to the second, which is social. Friends, family, intimacy. Once you get to that, self-esteem. Am I being respected? Am I, do I have self-respect, esteem from colleagues? Am I being productive? And finally, self-actualization. Am I the best person that I can possibly be? Am I being productive? Am I the best version of myself? Lots of times I think when people encounter this ladder, they start to question, okay, where am I in this pyramid? So let me answer this for you so that we can continue. I have a rule of thumb. If you have committed a single line of code in any open source project, you are here. Your self-actualization, you made it. That's congratulate yourselves, and it's all done for you. For some of us who haven't, we are stuck somewhere here. But that's a problem for a different day. So, how are the parallels? We started with measurement. We will analyze this, then control, then approximation, adaptation, and what we call the truth, which I think it's closer to where we are now. So how did this all start? It was before my days at Booking, but yes, let's explain that. Measurement. Provide the measurement of attributes of the platform customers care about. So that's the first step. We did not even measure at some point what we had. That was the first step. Then, control. Provide SLIs which we can justify and defend. This is very important. Approximation. Measure SLIs in a way that approximates closely the experience of customers. So it's not like what do you think, but what do the customers experience, and this is the trickiest part. You see, there is a lot going on in there. Adaptation. Define SLIs that cover specific customer needs, not something that you care about, it's easy, but something that is interesting to your customers. And finally, measure SLIs completely from the customer perspective, if you can manage to do that. So initially, Booking came to us with a business goal and a question. The business goal is, we have to have 99.95% of realized bookings. Every time that 10,000 people try to do a booking, only 5 of them is allowed to fail. So that was the business objective, and the question was, can you realize and measure this business goal? A lot of things go into this number, so immediately what we know is like every service that contributes to that has to have higher SLA than that, otherwise this will not work. But then we also find out that the measurements that we have were also not very clear. So we ended up with the first step, which is, okay, can we measure this? And we end up with 3 things that our customers care about and are important for the database infrastructure. Read availability. So how often and how easy it is to read from the databases. We measure this availability minutely on a per pool basis. Mohammed explained what pools are. And what we do is we have the pool, we open the pool. Are there a pool in there? Are there servers in this pool? Yes, there are. If there's one more, success. If not, the pool was considered at fault, and then that's a failure. The second thing is write availability. It's maybe the more important one. We measure this availability again by minute. We connect to the cluster's primary. We issue a query that verifies, is this primary writable? It is. If it is, that's fine. We are good to go. That's a success. Otherwise, there's a drop in the SLI. And finally, replication delay. 90th percentile of maximum replication delay in any replica is less than 15 seconds. We will get back to this. I know that this is a problematic definition. But that was the first step that we did. We discussed among myself and our customers at Booking. We say, okay, these are the important stuff, and we build the apparatus that will help us actually go and measure these things, and that was the first step. But immediately after we define those things and we start measuring, we encounter problems. The first problem, the first one that we decide to solve is control. Provide SLIs which you can justify and defend was the goal. Now, let's go over this one by one. Read availability. Can we control what goes in the zookeeper, what is in the pool? The answer is yes. Customer has no option to destroy or affect what is in the pool. So that is within our control, or the control of our automation. So that is a check. Write availability. Does the customer have ability to change the primary to make it read-only? No. Our automation has fully control of that. If something happens, we are at fault, we should be able to defend this. And then we came to this. Do we really control the replication delay? The answer is, although we did choose it because it's important for customers, you saw the slide before, right? The site. If any of these calls is delayed a lot, the whole page does not open, and then we have a lot of unhappy customers. So our customers care a lot about replication delay. That's why it's there, but the definition is obscure and convoluted, and it's like a joke. Like if you really have to explain SLI, it doesn't work. So the definition was not the best, and the reason was because we cannot really control it. Someone goes, executes an analytical query on read replica, the replica tries to execute, stops reading the binary log, and then we have replication delay, and then there's nothing we can do. Only thing is just wait for it to stop, or maybe kill the replica or the query. And that's what we did. And we ended up getting paged constantly, maybe in the middle of the night because Chrome was running and someone had to wake up because there was a drop in the SLI, go in, saw the thing running, and then just had to wait or kill the replica, and that was it. So we decided after a lot of discussion to actually remove the replication delay, so that's not an SLI anymore, and we changed it to replication running. One other thing that happened is, for customers, replication broken and replication running is the same thing. They cannot see why they have replication delay, but they can see that something is wrong. But for us, most of the times, unless the customer was involved, we experienced replication running. So the replication was broken somewhere in the hierarchy. And that is within our control. Customer usually cannot break the replication, so that is something we could control and it would be interesting to our customer. So we switched replication delay for replication running, and we were made one step closer towards this ladder. But then, came the approximation, and that was the difficult part. So this again is the definitions as we define them. But I think I don't have to explain to an educational people here about how this, why there is wrong here. Because, for example, opening the Zookeeper and finding out that there is two servers there doesn't mean that they are readable, right? That it's like I have like something in my house, a book. Can you go read it for me right now? No, you can't. The fact that it's there and it's readable doesn't really make it so. And the same for write availability. Having writable primary does not mean that the application actually writes, and having two members or more reporting in a pool does not make it actually readable. So there was a complete detachment from what our SLAs told us about and what was the experience of the application. And I think, let's hope this works. No. Yeah. That was, back in the day, one of the things that I did, that was in 2020, was on a weekly basis, go through, read this apparatus, export it to Excel, and have it reporting in the health reviews. And you can see, this is 15 seconds of a week, going through multiple of pools, and it's 100%, right? Never, it would have been mayhem on the outside. Within here, everything was okay, perfect. And we constantly saw this tension, right? Our reports were excellent, but outside the door, sometimes it was bloodbath. So, and it was at this time that we start thinking, okay, there are other providers, let's say, in the cloud that face the same problems. How do they figure this problem? Maybe we can get some ideas of how they go about. So, we consider the big four, AWS, Azure, Oracle, and Google Cloud. Now, arguably, these are not all equally big, right? But there is no reason for us to not be polite here. But we did consider all of them, all right? And this is the first thing that you see when you go and look at the availability of the services. You can see, for example, the worst are Amazon RDS for multi-agent deployment and shared Oracle Cloud, 90.95. Most of them are 99.9, and then there are two outliers. Autonomous database dedicated for Oracle and Azure SQL database that go a little bit higher. What you see here, and that's the most important part, is that it's only availability. Cloud providers offer availability SLIs and not anything else. And then we went into the fine print. How is availability? What counts as available or unavailable? Read replicas down, but primary works, it's still available. Failover happens, but complete within the provider's grace, still available. Performance degraded, but query succeed, still available. So, in essence, partial unavailability still counts as available. For example, most of these cloud providers have the clause that say you have to experience 1 minute of complete unavailability before the SLI starts to drop. So, that, for example, if that happens at booking, for 1 minute we have one booking, then we lock people like Mohammed in a room trying to figure out the problem, right?
At the end of the minute, we would be already in an incident call.
Right. But for most of cloud providers, that's not even a dip in the SLI. And there is, of course, planned maintenance, which is usually excluded. In Azure, it's explicit. Other cloud providers make it more via fine print. And, of course, planned misconfiguration on anything that you can do on your side. Maybe that's rightfully so, it's not counted. So you end up in this picture, which is the SLA is above the water. You can see, although there are these caveats, the failover, the DNS delays, cross-agent latency spikes, all of these things can affect your application, but they do not count. And there are all these things below the water that there are no SLIs for. Like there is no latency, throughput, query performance, failover time, backup subjects. All these things are not covered at all as a guarantee from the vendors. And they might appear in marketing docs or architectural guides, but most of the times they are not in the SLI contract. So now I would like to hand over again for one last time to Mohammed to explain how we went about solving this problem.
Okay, so we want to be able to solve this problem in a way that is as close to the application as possible. So in order to do that, we built an application. We tried to approximate the application behavior, build an application, It behaves like an application. All it does is that it is probing our databases. So it finds out if a server is writable and if the pool is readable. But instead of doing that from locally on the box, it does that from a Kubernetes cluster where most of our applications run. This way, we have integrated the check for service discovery and for the whole journey of an application query, starting from the application code, going to the database servers. It would be able to detect things like it would be able to detect things like degraded performance, network partition, all of these things. The way it works is that we have a control plane that is responsible for our service discovery and specifying our endpoints. Then the application, it's called the availability reporter. It's a Go application. It goes to that API, get all the list of all the endpoints, and then it does the probing. It knows how to probe primaries, it knows how to probe replicas, and then it emits metrics. These metrics then go through our metric aggregation pipeline, and this metric aggregation pipeline results in a single metric per endpoint. Then we do all kinds of aggregations. So a chain has at least 2 endpoints, one for reads and one for writes. If it has multiple pools, it might have other endpoints. So we aggregate also per chain, and then all of that feeds into dashboards for reporting and into our alerting systems, regardless what are those alert systems, and eventually it ends up escalating to either engineers or to tickets or whatever. And so as we said, it's an approximation. It's a great approximation because we went from being naively measuring our availability, not considering the applications at all, not considering our service discovery, not considering misconfiguration, network issues, etc., to a way that we are measuring from an external application. It behaves the same way as most of our applications in terms of retrials for connections, timeouts, endpoint discovery, everything like that is the same to most of our applications. It can detect, as I said, network partitions, etc. And we could see clearly from the day that we started using this application that it is doing what it's supposed to do. We can always align database problems that we notice in our monitors with availability problems. But it's still an approximation, so it's still an abstraction layer that is hiding a lot of information behind it. So this is a Golang application. Most of our applications are Perl or Java. We have some Python and other languages. It would be crazy to build an application per language, and we just moving between those and managing those would be a hassle. And any problem with the availability reporter means an availability problem. That could be either a storm of alerts that we get, causing alert fatigue because there are a lot of false positives because there is a bug in the reporter, or it could be the other way around. The reporter isn't emitting the right metrics, for example, and we end up with missing alerts. The other thing is that it's an extra application. We maintain a lot of automation at Booking, and this is an extra application that has to be maintained. So, but again, it's the best that we can get at this point, and there was a sense of satisfaction for our customers as well. I think we managed to reduce their expectations extremely by the first approach, that the second approach seemed to be brilliant. Then we move to the adaptation part. So we have 350 clusters. Some of them are serving the page that you show in the beginning, and some of them are just holding analytical data. Some of them are just there because why not? And everything was falling under the same SLO, meaning that all of them need to be available for writes 99.97 or 95% of the time. What this means is that if one of those why not databases is down, nobody cares about it, or it could be down for 1 day without anybody noticing, I would still get a pager alert in the middle of the night and I have to wake up and deal with it. So what to do about that? Also, it could be the case that customers don't really care about certain periods of unavailability. Some customers love to run cron jobs in the middle of the night, and those cron jobs could be heavy. They could be running huge transactions or hammering the database with small transactions. Any of those would result in unavailability of the database, either for reads or writes, and that would again materialize into an alert on my end. But the application owner who I created the alert for because I care about doesn't care. So yeah, care has to go both ways. So yeah, the result of that, alerts that nobody cares about, alert fatigue of course, and also I have to disrupt the customer. So when I see that the customer is abusing the database, I have to ask them to stop abusing the database. So that's two people woke up in the middle of the night fighting each other, and that's never fun. So then we introduced the concept of custom SLOs, or it can be viewed as productization. So every database now has its own SLO. We can say that for this specific database, it's okay to have 99.9 target of availability instead of 99.97. That's okay because that's what the application expects. And as you see here in this column, for example, we have some SLOs that are 99.97, and we have 3 nines, we have 2 nines and a half, 2 nines only, and it varies based on the application behavior and the expectation from the database. And another thing is that we have databases that don't have pools. It's either because it's a third-party tool that only deals with a single endpoint, or because the load is low, so they prefer to read data consistently. Everything happens on the primary. So how would you offer read availability for that? It's that you make the probe also probe the primary for reads, but primaries have different expectations. A pool has 3 to 15 servers, for example, but the primary is always a single server, so the chances of that failing are higher. So its availability SLO is by definition lower. So that's why we measure the read availability from the primary, but with lower SLO. And everything that you see here with star next to it is a custom SLO or different SLO. And these are some chains that don't have pools, so their SLO is the same as the write availability SLO. Okay, and then we wanted the truth. We wanted to reduce the approximation as much as possible, and we wanted to be able to view this from the application side. But remember, we have multiple applications, multiple clients, multiple platforms. We would need to touch all of those to embed the right metrics with the right tags of the metrics and put all of that into the metric aggregation pipeline. Some of our applications are very sensitive about CPU usage or network usage, which means that emitting an extra metric is going to be heavy for them, so we don't want to do that. So here comes an important and very a tool that is close to my heart, which is proxy scale. So we adopted proxy scale a few years ago. We adopted it mainly for other reasons. One of them is it can do faster failover and switchover between endpoints, optimal connection handling, which was a big problem because we had some applications that were doing a lot of connections to the database, so proxy can solve that problem and maintain the connections open for longer time, but also can give us better visibility and metrics, which is something that was very interesting to us. So last year, Rene was here. He announced that the advanced event and the query logging is now supported in proxy. That's a feature that was requested by Booking. We actually sponsored implementing that feature, and it is available since version 2.7.2. And what happens is that proxy now emits metrics for connection failures, for example, query failures, etc. And these metrics we can adapt to use as our SLIs. So here is how proxy works. So pull changes happen, they end up in Zookeeper. Then we built a tool called proxy SQL configuration agent, which subscribes to the changes in Zookeeper and configure the pools in Zookeeper as host groups in proxy SQL. And then applications would be connecting to proxy SQL, which maintains connections to different primaries and different applications and different read-only replicas. And it could basically serve any application. So it now runs with Java applications, Perl applications, and bare metal applications, and Kubernetes as well. So as I explained, proxy can now detect failures. It can detect timeouts, etc., and emit metrics that we can then use in our metric aggregation pipeline. And now the benefit of that is that now we can detect partial failures. So when there are, as I said, we have multiple platforms that our applications run on, but all of that isn't visible to us. We only know about our probe application. If that fails, we know that there is a failure. What happens if there is a failure in a specific region? What happens if there is a failure on bare metal servers where our probe doesn't run? So proxy now resolves that problem for us. Now we can see all partial failures. Now we also, that's a very important concept, application first reliability. Now we know what impacts the application, how the application is going to see errors, and we know what really matters to be resolved first in order to ensure that the application doesn't see those errors. And of course, signals are now, metrics, etc., are coming based on real issues. And now, in combination of the backend or metrics that we have, the probe that we have, and proxy, we can improve our alerting. For example, if we see an issue with a single application, then probably it's the application, a recent rollout, for example, caused this problem. Its connector is bad or whatever. But if the issue is global and it is seen in the different metrics that we collect, then this is a global issue, and now we can try, and now we get an alert and we know that it is a database issue. So this is how the view now looks like. So this is one of our applications, and here this is the right availability. We can see per database or per primary how the availability is, and we can see that some of them are low, some are higher, and we can see here which ones the application is impacted by. The same for reads, it's per pool. We can see which pool has the lowest availability for the application, and we can try to do something about it. So, yeah, I think that's it. I hope that was interesting, and yeah, I think we have time for questions.